Okay, hello everyone. I'm Tamara and I'll be here as tech support during the tutorial. I'm very pleased to introduce you our tutor for the last session of the day, Miroslav Tomic. Miroslav is a teaching assistant at the University of Technical Sciences faculty, University of Novi Sad, and he will hold an introduction to orchestration ETL processes with Apache Airflow tutorial. Enjoy.
Thank you very much, Tamara. Hello, everyone. From my side, I hope that you can hear me well. Today I'm gonna present you some basics about Apache Airflow and orchestration of ETL processes. I really hope that you are not too tired to listen to this tutorial since this is the last one for today. So if you have any question, do not hesitate to ask. I will try to take my eyes on the chat, but if I miss something, I will answer later. Or if it's something urgent, maybe the host can inform me about that. So I also hope that you can see my screen. If anything is broken, please just tell me on the chat so I can fix that. Okay, all good, thanks. So let me start with my presentation. So my presentation materials are located here at the Data Science Conference, but you also have my GitHub account. So if you want to also put hands-on, it is possible with this tutorial. You can download the code from the GitHub, and also you have a PDF of my presentation there. Okay, let's start with some basics first. So today we will cover some basic things into introduction. We will see some basics about Apache Airflow, and also we will get known tutorial environment as well as examples that I prepared for today. So what is Apache Airflow? That is one open source platform for developing, scheduling, and monitoring batch-oriented workflows. Workflows can be built with almost any technology, which is possible because of Airflow extensible Python framework. State of workflows are managed with help of web interface, and one of the main characteristics of Airflow workflows is that all workflows are defined in Python code. So here you have a concept that's known like workflow as a code that serves several purposes. So first of all, it's dynamic. Airflow pipelines are configured as Python code that are allowing for the dynamic pipeline generation. It's also extensible. This Airflow framework contains operators that can connect with numerous technologies. All Airflow components are extensible to easily adjust to your environment, and it's also flexible. Workflow parameterization is built in leveraging the Jinja template engine. Okay, so this is just brief introduction. So just to see more clear, here is one snippet of the code. It looks like standard Python code. Here you have imports, and you are importing something from the datetime library from Airflow. Okay, and then here is Python code. You can see here that you have some DAG. We will talk about DAGs, but it looks like instantiating of some class in Python. And here also you have some operators, some tasks, and here you can see some dependencies between these tasks. Okay, this is just briefly to see this code. Let's talk about Apache Airflow. So how you can install this Airflow? It is possible to perform multiple types of installation. You can use release sources to run it on your local machine as standalone solution. Of course, you can use PyPy to install this as library, and you can use Docker images or some third-party images, jars, deployments, etc. So here in this tutorial environment, I use Docker images because of the isolation and the simplicity of using through the Docker images. So what are the prerequisites? So you need to have some Python version from 3.8 and above. Also, you need some database like Postgre, MySQL, SQLite, and MS SQL that is deprecated, but usually I like to use Postgre very much. So in this example, I prepared Apache to work with Postgre. Of course, you can use this in Kubernetes cluster if it's a requirement, but here we are using this just in the Docker environment. So let's talk about just briefly about this architecture of the Airflow. So workflow is represented as a DAG or directed acyclic graph and contains individual pieces of work called tasks. Okay, so DAGs specify the dependencies between tasks and the order in which to execute them and run retries. Okay, so an Airflow installation consists of the following. You have scheduler, which handles both triggering scheduled workflows and submitting tasks to the executor to run. You have executor, as you can see here. So executor handles running tasks. In the default Airflow installation, this runs everything inside the scheduler, but most production suitable executors actually push tasks, execution tasks out to the workers. So that's the situation where you have separate machines for the workers. And here in this architecture, you have one web server, which presents a handy user interface to inspect, trigger, or debug the behavior of DAG and tasks. Also, you have one directory that contains code. Yeah, here you specify your DAGs through the Python code, and this can be read by scheduler and executor. Also, there is a metadata database that's used by scheduler, executor, and web server to store the state. So yeah, data about the execution, about the failure or success of your tasks and DAGs are stored in this database. So this is just brief architecture overview of Apache Airflow. And yeah, I mentioned the workloads. We want to say that DAG runs through a series of tasks. So DAG represents as one wrapper around the tasks, and you can specify multiple things with DAG, as we will see this in the presentation. Of course, there is a control flow. DAGs are designed to be run many times, and multiple runs of them can happen in parallel, and DAGs can be parameterized, of course. Also, you have this user interface. Airflow comes with a user interface that let us see what DAGs and their tasks are doing, trigger runs of DAGs, view logs, and do some limited debugging and resolution of problems with DAGs. Okay. So now I will just introduce briefly these concepts just to be aware of them. I'm not sure if you ever worked with Airflow, but this kind of tutorial is like for beginner to intermediate, as I mentioned. Beginner in the means of we are covering some core concepts of the Airflow, and intermediate in the means of technology that we are using, the Python language Dockers. But of course, I think that anyone can follow this tutorial easily just to get familiar with these concepts. So here, DAG, directed acyclic graph, is the core concept of the Airflow. It collects tasks together, organize them with dependencies and relationships to say how they should run. You are specifying something to run as a series of tasks. So DAG could be declared with context manager, with standard constructor, or DAG decorator. Here you have many examples in the official Airflow documentation. I used here a version 2.7.2. So please, I put those links here because I don't want to bother you with the old concepts that it contains, since we have time limitation here. And of course, it's not mandatory to know all of them in first place. Okay. So something about task. Task is a basic unit of execution Airflow. We can say it's like some function in the Python. Tasks are arranged into DAGs and then have upstream and downstream dependency set between them in order to express the order they should run in. So there are three basic kinds of tasks. They are operators, sensors, and task flow decorated tasks. Okay, so now I will just open one example from this tutorial environment, this hello world DAG and task. So as you can see here, maybe I should just zoom this. Here is decorated DAG with some specification here. And inside this DAG, that is also Python function, you can see two Python functions that are decorated with task decorator. And at the end of this DAG function, let's call like that, you have here specification in which order to execute those tasks. This is one way to specify that hello world task should be run first, then from DSC, and this in comment specify that these tasks should run in parallel. Okay, later when we run the whole cluster, we will of course execute this DAG and try and we will see the behavior of this DAG and these tasks. Okay, so I will switch back to the slides. No questions for now. Okay. Okay. So let's talk about the operators.
Sorry, for everyone, feel free to pop any questions in the chat and Miroslav will tend to them. You can go.
Okay. So yeah, an operator is conceptually a template for a predefined task. Operators can be defined declaratively inside the DAG, and Airflow has a very extensive set of these operators, but the most popular are bash operator, Python operator, and email operator. As I said, operator is basically a template for a predefined task. Of course, you can always extend some of these operators or create your own operator, however you like to use these concepts from the Airflow. So sensors, what is a sensor? That's the special type of operator and is designed to wait for an event. It can be time-based or waiting for a file or an external event. But sensors are primarily in the idle state, and they have two different modes of running, poke and reschedule. So in the poke mode, the sensor takes up a worker slot for its entire runtime. And in the reschedule mode, the sensor takes up a worker slot only when it's checking and sleeps for a set duration between checks. Okay, I implemented this in my tutorial in my example, so we will see this behavior of the sensors. Okay, so the task flow. If code is mostly written using Python instead of operators, then the task flow API will make it much easier to author clean DAGs without extra boilerplate, all using the task decorator. Task flows take care of moving inputs and outputs between tasks using XComs. Okay, so you saw in this example that you have two separate tasks as two separate Python functions, but how can you pass the parameters and values between them? Of course, sometimes you can call one function inside the other, something like that. But you can also transfer the data with this concept that's called XCom. So first, let's say something about the executor. Executors are the mechanism by which task instances get run. They have a common API and are pluggable, which means that they can be swapped based on the installation needs. So you can check which executor is currently set with this command. So I mentioned that you can use Apache Airflow through the web interface, but also you can use Apache Airflow through the command line interface. It's possible. It's not so like easily to see and to use, But yeah, sometimes it's mandatory for you to use on that way. So now let's speak about these XComs. XComs, or short for cross communications, are a mechanism that let tasks talk to each other. Let's say like that. By default, tasks are entirely isolated and may be running on entirely different machines. That's also the case. Your task can be run on different machines if you have multiple workers. And one XCOM is identified by key, which represents its name, task ID, and DAG ID. So XCOM can have any serializable value, but they are only designed for small amounts of data. They shouldn't be used to pass around large values like data frames, and XCOMs are explicitly pushed and pulled to or from their storage using the XCOM push and XCOM pull methods on task instances. And XCOMs can be also used in the templates, not just in the code. You can see one example here. So you specify some SQL command like select something from something, but here you can see that with some task instance and XCOM pull, you're pulling like probably the table name. Yeah. So after from keyword, we expect to see the table name. And as you can see, the task ID is full and the key is table name. So we want to pull a value from the XCOM that's called table name that belongs to this task. This task generated this value. Okay, we will also see this in the examples that I prepared. So what are the variables? So variables are Airflow runtime configuration concept. That's some kind of general key value store, and it's global and can be queried from tasks. They can be easily set with Airflow's user interface or bulk uploaded with as a JSON file. So they can be used in code by importing variable model and calling some get methods on it, or in templates. So variables are global and they shouldn't be used to pass data between tasks, and they should be used to configure for configuration that covers the entire installation. So according to the Airflow documentation, it is recommended to keep most of setting and configuration in DAG files so it can be versioned using source control. And variables are only for values that are truly runtime dependent. Okay, so of course, it's mandatory requirement, yeah, if you are using Apache Airflow in your project to use some kind of source control like it. And you should put all your configuration inside the DAG. But if you have some values that are really runtime dependent and that are global, yeah, they should be stored as a variables. Beside the variables, there are also parameters or params here. They are used to provide runtime configuration to the tasks. Default parameters can be configured in the DAG code, and also additional parameters can be added. So it is possible to override parameters values at runtime when DAG is triggered. Parameters are validated using JSON schema that should be provided, and for the scheduled DAG runs, default param values are used. We will see also this concept of scheduled DAG. So this is just briefly about some main Apache Airflow concepts. And there are also much more of these concepts, but I think that we should put our hands on this tutorial and to see some practical examples here. Do you have any questions so far? Okay. If there are no questions, I will continue. So in this tutorial environment that I prepared, Docker is used to simulate real scenario because I really don't have multiple machines that are ready to be workers and one web server. So this is just small playground. So project is divided into different units, let's say like this, that are containerized, okay? The one unit is Airflow that is used as orchestrator. It contains Docker configuration, Airflow configuration, and DAGs. The second unit is a Microsoft SQL database that's used as a source database here, and it also contains these configurations and database backups and script for restoring backup. And the third unit here is Postgres that's used as a target database. It also contains this Docker configuration and script for creation of initial schemas and tables. Okay, so just to mention what is ETL, it's extract, transform, and load process. So we are speaking about ETLs, not ELTs. So this concept is pretty old. So we are using it every day as a data engineers, and we are using this like to extract data from one source, to apply some transformations, and then to load this data into different source. Okay, so I will open now this environment, and now I will just go through this setup. So here you have directory scripts that contains two type of script. One is cluster up. I created this script to be easily to start these Docker containers. It will first create one network, because all our Docker's containers should be in one network to be visible between each other. So to ensure this, first step is to create this network, and we will see in the configuration of these Dockers how you provide that it should use this network. Then we are starting Microsoft SQL Server, then Postgres, and the last one is Airflow. After we start these containers, we need to configure something. Here, I'm just moving backups, or I'm just applying restore function for Microsoft SQL database. Then I'm also doing some basic setup for the Postgres database. And the last thing here, we are setting up some Airflow objects that we need. Okay, so let's see Postgres configuration. Here you have the Docker Compose file that is used to specify multiple Docker containers on one place. Here I used Postgres image Postgres 16 version and created container with this name and provided these environment variables. Also, I exposed the port of this Docker container on my host machine like this, because this is the Postgres default port. And I use some volumes. One volume is bind mount. Here you can see config. It contains two files. One file is bash script for applying some, running some SQL script that you can see here. So this initial setup SQL script is to create some data warehouse, small data warehouse inside the Postgres database. I will speak more about this concrete example later. Let's just see this architecture here. Also, the second volume is a classical Docker volume that will persist data between restarts of this Docker container. Okay. This is some basic configuration. As you can see, I specified that it should be inside the Airflow network. This network is introduced here as an external network. So this is the configuration of the Postgres database. The configuration of Microsoft SQL database is located also in the Docker Compose file. Here I used MS SQL version 2019. This container is named SQL Server, and it's exposed on its standard port. It's 11433. And here are some environment variables that are mandatory in order to run this database. And also here are two volumes that I bind mount. So I'm mounting these two directories to my Docker container to be able to run some scripts and also to be able to read backup files that we need. Also, this container is inside Airflow network. The last thing here, and the most important for this tutorial, of course, is Apache Airflow. So here we don't have only one Docker file, let's say like that, or Docker Compose, but also we are using here Docker file. Let's start from there. So I want to use default Apache Airflow image from the Docker Hub, and I want to use this version of Airflow. But also, I want to extend immediately before its creation with some additional libraries that I need. So in this Docker file, you are specifying which layers your Docker image should contain. So it will contain base layer, this base image for Apache Airflow, and then we will copy this requirements.txt file inside this container and install those libraries that are inside this file. Also, default user will be Airflow, and the working directory will be on this location. So as you can see in this requirements file, you have some libraries that should be installed. Here, there are some Apache Airflow providers for Common SQL, also providers for Celery that's used for Airflow engine. And as you can see, these two libraries, you can suppose that they are here because of the databases that we will read from and that we will write inside. So we need this provider for Microsoft MS SQL database and also for the Postgres database. These are not just Postgres library or Microsoft SQL library. As you can see, this is Apache Airflow provider. So Apache Airflow has multiple providers, okay, that you can use for things like not just the databases, but even more like some big data things like Hive, like Spark, etc. Okay, so there are many things inside this Airflow. But also, I need to say something about the documentation for the Apache Airflow. It's pretty large. It's not so easy to to find what are you looking for. You need to spend some time to get used on their interface, on some explanation that they have to be aware in which section you are. So it's not so super easy to read from that documentation, but you can definitely find anything that you need there. So let's get back to this Docker file. So this is the basic configuration of the Docker image, but as you saw already, Apache Airflow has multiple services, and this Docker Compose file is downloaded from their official GitHub account or GitHub repository, sorry. And here I just modified a few things. It's like network to be sure that also Apache Airflow is in the same network. Also, what I did here, I modified this default database that's used like a metadata database for the Apache Airflow. And other things, I think that I didn't modified anything here. So here you have a specification of the multiple Airflow services like Airflow init. This container is run on the init phase to apply some configuration. And as you can see here, almost every container here or any service inherits something from this Airflow common thing here in YAML. So Airflow common is like some anchors, reusable values that are used, that can be used in the multiple places in this file. Okay, so here, for instance, you have specification of salary broker URL or result backend or SQL Alchemy connection that should be used, etc. So this is pretty a large Docker Compose file, and for the initial use, you don't have to edit almost anything inside this, but of course, if you want to customize this, you always can, but yeah, you need to be careful to not to miss something important inside this file. I will not go so much in depth with this file. You have everything here in my project, and you can take a look on the official Apache Airflow repository. So what else do we have here inside the Airflow directory? One thing is this configuration directory with setup Airflow objects bash script. So what is this? This is script that is executed after a successful startup of Airflow container. And with this script, I'm specifying something with Airflow CLI commands. As you can see here, I'm specifying three type of connections, three concrete connections that we need for our examples. One connection is for SQL Server from Microsoft SQL database. The second connection is for Postgres data warehouse, and the third connection is for initial, for Airflow metadata database. So beside variables parameters, there is concept that's called connection. So your Apache Airflow, usually you are using Apache Airflow usually to connect to some database, to some data source or something like that, or even some API, and you can save these connection parameters inside Apache Airflow. We can do this through the web server interface or with Apache, with CLI commands. So for the initial connections and variables, I used Airflow CLI because I want to demonstrate usage of this CLI and for you to have something to extend later if you want. Also in the last section of this script, you have variables. I also set one Airflow variables that I named SQL chunk size with the value 20. We will see how we read this value inside our tasks and DAGs. Okay, so this script is executed after in cluster startup after our Airflow is successfully started. So I'm executing this script on this way. I'm providing this bash command to the Airflow container here on this way. And it will be executed inside of the container, and it is possible because this config directory is mounted to the Airflow container. So for the ones that are using Windows PCs, you need git bash in order to be able to execute these two scripts, okay, to start and turn off this cluster. But also you can execute these commands one by one from the PowerShell. I think this will work. Okay. What else to mention? Yeah, let's continue with Airflow. Here you have additional directory that's called DAGs. Inside this directory, example, the logs and plugins directory are directory that are used by the Airflows. It is mandatory to create them manually before the start of the Airflow. In if you don't create them, then Airflow just won't start because it says I can see logs or plugins directory. And the data inside of them, it's maintained by the Airflow, especially in the logs. And we are not using this for anything, but it's mandatory to include them. I escaped this with git ignore, so it's important for you to create these two directories after you download my code. Okay, that's all about the structure of the Airflow, and let's just mention this cluster down script. This script is created for you to be able to shut down the whole cluster at once, and also to choose if you want to delete all the volumes. If you don't want to persist data and to have the same data on the next startup, then you should answer with yes to delete these volumes. If you answer with any other option with no, yeah, then we will just shut down these containers that we are using. And of course, at the end, we will delete this Airflow network. Okay, so now I spoke something about the architecture, the initial architecture and structure of this project, but now I need to provide you a context why I created these two services and why are we using the Airflow. Let's get back to the presentation. Okay. As you can see here, so basic idea is to demonstrate usage of the Apache Airflow for creation and orchestration of these ETL processes on examples that are easily understandable. Okay, I didn't create something super fancy or huge to impress you, but this is just created to be easily understandable. So for this purpose, examples that we need are located on this link. So I came up with one idea. Okay, I want to have one OLTP database, so online transaction processing database that stores the data on day or hour level for the transaction processing. And I want to create one OLAP or online analytical processing database or data warehouse to store data that is aggregated and that is coming from the OLTP database. So I thought like this. I want also to have two different sources, two different databases. So one database that is source database should be like Microsoft, and the target database where our data warehouse will be located is Postgres database. So it's also two different technologies. So we are reading data from one database, then we need to transform somehow this data and to load into different database. So I was thinking which data should I prepare, and I find on the Microsoft SQL database website some examples for the learning concepts of the MS SQL. And you have these two databases, OLTP database and the OLAP database here. Because I used the 2019 version, then we need these two backups. So actually, we need just OLTP database to be able to read data from there. But I also downloaded this data warehouse example to see how they build this data warehouse from this OLTP database. Okay, so and I also implemented inside the code on the initial startup of our cluster here. Just a moment. Let's see the setup. To restore these two databases, one OLTP and the other one is OLAP databases, the both database, just to see their structure. Okay, so after this, by looking at these OLAP databases that we have from the Microsoft, I created a schema for the target Postgres database, but that schema is just small schema just to be able to run these examples and to understand them easily. So as you can maybe if you don't know so much about the data warehouse, it's completely different. Data tables are completely different organized than inside the OLTP database. In OLTP database, a relational database, of course, you should have normalized data, normalized tables, but inside the data warehouse or OLAP database, we are going with the normalization of this database. And the main concepts that we have there are the fact tables and dimension tables. So I will not go so much into explaining these concepts of data warehouse, but you have one table for the facts and the dimension of these facts. Okay, so in our examples, we have some currency rate fact table with some ID, date rate, average rate, end of date rate, and yeah, some currency ID. That is actually the foreign key from this dimension table that represents currency. It has its own ID, currency code, and currency name. Okay, I think that this is pretty simple. So inside our target data warehouse, we have just these two tables, one fact table and one dimension table. Okay, so let's see what we have inside the source database inside the Microsoft SQL database. So we should start our cluster now. How do we start our cluster? If you are located inside the root of this project, then you can execute this cluster up script on this way. So you are executing this cluster up file. As you can see here in the cluster up, we are first starting Microsoft SQL Server or our OLTP or our source database. Then we are starting up the Postgres database, our OLAP or our target database. And the last container to start is Airflow. As you can see, it contains multiple services or multiple containers. I can see one question. Yeah, it is on the GitHub, and you have a link provided here in the chat, if you can see. So after the startup of these containers, you have one sleep command here. The reason of it is just to be sure to have all services started. And as you saw, we applied our restore script. This output is not so pretty here. And I had some issues with creating schema inside the my Postgres database. The reason is because I already have created this database. So I'm using dbeaver as an open source tool to connect to the database and to see the tables, to see data inside of these tables. So you can see whatever, like maybe data grid from JetBrains or some extension for my Visual Studio Code or anything else. But it is important to be able to connect on any databases, or in our case, on these two types of databases. So when I connect to our OLTP database, I can see that I have actually these two schemas here. One is OLTP, the other one is OLAP. And inside this, actually it's called the database, sorry, in Microsoft SQL. We have this OLTP database with its own schemas. And I can open actually the complete ER diagram of this database. So this is some OLTP database about some sales, about the currency rate, currencies, currency region, etc. Okay, so here are like 26 tables, I think, and we will use only this schema sales, and we don't have to go so deep inside these examples. Also, when we take a look on these data warehouse databases, we have one schema here, and I can open also here diagram of this schema. As you can see, here is our data warehouse with some facts and with some dimensions around them. So one fact here is currency rate and dimension currency. So that's the reason why I decided to use these two tables in my PostgreSQL database. Okay. So we will not use this data warehouse database anymore. Let's now take a look on our target database here, data warehouse. I created a schema here, and here are located my tables inside the PostgreSQL database. And as you can see, here is the fact table and dimension table. Let me just see if I already have some data inside these tables. It looks like I don't have any data here for now. Okay, so this is all about our databases and the tables that we have inside them. Okay, so now it's time to open our Airflow web server and to see this interface. So the credentials for the connection are Airflow. And when you open this, you see multiple DAGs, but we have only our three DAGs, or 4 DAGs actually, but the other ones are default examples from the Apache Airflow. Just to, if you want to experiment some little bit with them, you can turn off these examples inside the Docker compose of the Airflow. I think, yeah, here is some environment variable where you can specify false if you don't want to use these, to load these examples on the creation of these containers. Okay, so I prefixed our DAGs with the DSC, and before I open them, I just want to show you here in the admin menu, you have connections. And as you can see, you have 3 connections that we specified with our startup objects bash script, and we created these 2 connections for our source and the target databases. Okay, and also for the metadata database of the Airflow. Also in the variables, you can see that we have created a SQL chunk size variable, and you can add a new record. Of course, you can specify these variables through the web server interface, as well as the connections. Okay, so I will get back to the DAGs. Now I will open our first DAG that's called DSC Hello World. So it's disabled for now, and by default, or our created DAGs are disabled. In our DAGs, we can see here DAG docs. Okay, you can specify documentation in line with your code. In the commands, it will read and it will display here. You can specify this documentation for the DAG or just for the tasks. Okay, so how you run these tasks? You can press here trigger DAG, and you can also enable it. Okay, now I enabled this DAG, and I will enable this auto refresh. Let's see if something will happen soon. If it doesn't happen, then we will just reload page or just get out of this and return inside this DAG. Okay, nothing happened. What's the reason? Let's see the code. We can read the code also from here. So, as you can see, I specified for my DAG beside the ID and the description, specify that it should start on this day and the schedule interval is monthly, and we can run only one DAG in parallel, DAG, not task. Okay, so if we take a look on this Gantt, it should display for this DAG when it should be run, but it's not displaying currently, maybe after our first run. So it will not trigger DAG immediately to execute anything. Then we should press trigger DAG. And as you can see here, you have this one line for the execution. And the first one is executed successfully, as well as the second task, and the whole DAG then is executed successfully. So you can see here, when I press here on one task, I can see the logs inside this. And if you remember, we print out the hello world here in our first DAG, and it's really printed here. In our second task, we also print out something else. It was hello world from DSC Europe. And here inside our code, I will get back here. There are two functions. As you can see, one is print hello world, the other one is print hello world from DSC Europe, and it really does that job. Okay. Now let's take a look at the Gantt chart. Yeah, we have this one run information about running this. Also, when we take a look on this graph, we can see that hello world task should be run first. The second one is from DSC. And inside these details are summary about our task. Okay. And that's pretty much all about this basic concept of the running DAG and tasks inside of the DAG. Okay, so let me just change something here. So I will change the relationship between tasks. Firstly, the order of the execution. I want that these two tasks execute in parallel. So I will just change my code like this and save. And our DAG should load, our web server should load this change. Let's see our code here. So as you can see, code in web server displays here that these tasks should be run in parallel. Let's see the graph now. It's not refreshed. So I will just refresh here. And you can see they will be run in parallel. There is no line between them. There is no dependency. So when I run our DAG now, they are both running, and as you can see, it took less time to execute them. Okay, so this is successfully executed, and as we can see here in the logs, there are some messages that are printed out. Okay, so this is the basic DAG that is scheduled only to be run once per month. Yeah, let's see the Gantt chart here. You can see the only details for the for this DAG, for these runs. Okay, there are many things that you can see here. Calendar. Now you can see that we run this DAG today. There was 2 success running of it, and next run is planned for this December 1st, because I specified inside our code it should be run monthly, and the first run was on November 1st. So the second run will be at December 1st, and it's correct here in our calendar. Okay, so I'm scheduling the execution of my DAGs. Okay, so we are responsible for that. Okay, so this was just introduction example. So now let's take a look on the other examples. Let's get back to the presentation. So the first example DAG is called DSC load currency. So purpose of this DAG is to demonstrate the initial filling of dimension table in OLAP database. So inside the data warehouse world, when you create the data warehouse, you have initial loading of data. Okay, so now we want first to fill these dimension tables. So I just want to transfer all currencies that I have in my OLTP database inside our data warehouse database. So let's see here inside the sales, inside the table that's called currency. Here you have multiple values. You have 105 currencies with its currency code and the name, and some attribute that we don't need inside our data warehouse. Okay, so I want to extract this data, to transform this a little bit, and then to load inside the data warehouse. How can I do this with the Airflow? So DSC load currency. I'm specifying one DAG that's called DSC load currency with this description. It should be executed on this day, and scheduled interval is once. Because we are filling our dimensions initially, it should be only done once. So I'm not scheduling actually this DAG to be executed multiple times. It has only one task or one function that's called load currencies. Inside this function, we are creating this Microsoft SQL hook. So how we will connect to our database? We will connect with MS SQL hook that's imported here from the Airflow providers. And after we create this hook, we can we can execute some code with calling the functions get pandas data frame. So actually, Apache Airflow shouldn't be used to store data inside of it in the means of the memory. You shouldn't load so much data with Airflow, but this is just the basic concept. So even with data that is much larger than this, it will work, but it shouldn't be used like in the big data to load all data inside the memory of the Airflow like this in some data frames. But for the purpose of showing this how it works, and also because our data is not so large, it's fine to be used like this. So when I call this function get pandas data frame, it will execute this SQL command inside the Microsoft SQL database, and all the data that is retrieved will be put inside the pandas data frame inside these columns. Okay, it will be just currency code and the currency name. And after we retrieve this data, we will print the number of the rows and also the name of the column, just to see here. After this, we want to load this data inside the Postgres database. We will use the Postgres hook also to connect to our Postgres database. And as you can see here, you have a method that is called toSQL, where you can specify in which table you want to load your data and which engine to be used, and also in which schema does this table is located, and do you want to append if some data exists or you don't want, and of course if index of this data frame should be included. Okay, so as you can see, I have only 2 columns here inside this data frame, and I'm missing the key, the column for the primary key. But primary key is specified to be auto increment key and will be appended automatically after insert command is executed. Okay, I didn't divide these 2 things into separate tasks because of the transferring this data. We will see later how to transfer data between the tasks. Okay, let's execute this now, but let's first see if our dimension currency table inside the Postgre is empty. It is really. So now I'm switching back to the DAGs, and I'm running this DSC load currency. And now it's executing, and it's already successfully executed. Inside our logs, we can see that the number of the rows inside the data frame is 105, and also that we have these 2 columns inside the data frame. It's the same like in the our source database. And now when I open this dbeaver and refresh, we can see that we loaded successfully all these currencies inside our data warehouse. Okay, so it's the same data transferred from the from the source database without this modified date column because I applied some transformation along the way. Okay, so this is the first DAG that we used for the purpose of ETL processes. Okay, so what's the second example? The second example is called DSC load currency sensor. So purpose of this DAG is to demonstrate update of dimension table in OLAP database. So now we could ask a question. You executed only once this initial loading, but what happens if a new currency is created inside our source database? I want also that to be loaded inside the data warehouse or target database. So for that purpose, we are using Airflow concept that is called sensor. And I will open this here, and also we will take a look on the code. Here inside this DAG, that will be run only once, okay, because the sensor will be run multiple times and will always check for the new data, and then it will execute again. Okay, so here, as you can see, you have first task that is called get currency count. So how do we know that new data appeared in the source database? So we will count the rows inside the source database and compare this count with the count of the rows inside the target database. And if it is different, then probably new currency is inserted inside the source database. So first, we want to retrieve the number of the rows from our target database. We will execute this SQL command, okay, and if number of records is greater than 0, then we will print out the message. If it's different, then we will raise exceptions that we don't have any records found, and to make sure to perform initial load into a dimension table. So this task or this function returns the number of records. So our second task here is actually SQL sensor that is called wait for new currency records. It should connect to SQL servers, to Microsoft server, and it should execute a SQL code that is located inside this file here. So if you have any code that should reside inside the files, then you can do this on this way. And I want immediately to return the value from which I will know if something changed inside the source database. So I want to count the rows inside the source database, and to make distinction between counts inside the source database. And to be able to load the number of the rows inside the target database, I'm using XCom now. So I'm using this template. I'm allowed to execute this SQL command like this. I will count all rows minus all number of the rows from the target database. This task instance will pull return value from the task that is called get currencies count. Okay, so our first task was, was get currencies count, and we saw that we returned the number of the records. And now when we calculate this, if it is 0, then it means that there are no new data. We should wait for the appearance of the new data. And if it's larger than 0, then we should load this difference. How we proceed? So there is third task here that is called load new rows into dimension table. We also are connecting to Postgres hook, and we want to retrieve all currency codes from that table, and also to return only currencies from the source databases that are not located in this list of the currencies from the target databases. It may sound complicated now. I'm really sorry. We don't have so much time to explain this in detail, but I want to retrieve only currency codes that are not located inside the target databases. So I'm just here executing some SQL command. And after I return this data formatted like this, I want to insert this data inside the target database. Okay, so I'm doing this on the same way as before. Okay, so let's trigger this DAG. Oh, there are two DAGs that are triggered. Never mind. I will just mark state failed for the first run. But as you can see here, it's waiting for new currency records. Okay, and nothing changes here. Let me insert a new currency inside the source database. I will insert bit like Bitcoin. Okay, and now I save this inside the source database. As you can see here, it's not waiting for new records. It actually it looks like it detected that there are new reports and executed the other tasks. And let's see now inside the dimension currency table inside the data warehouse, if something new appeared. Yeah, here is the Bitcoin currency. If I enter the new value, like I'm really not sure if it's like this, but let's see here. It waits for the new data to appear. It waits, and after it will check. It check. There is new data here, and now I can proceed, and I can load this new data inside the data warehouse, inside our target database. Okay. So here is the concept of the sensor explained, but we could ask a question, is this good practice to have sensor here on this place like that? Maybe the new currency will appear in the 6 months. Okay, yeah, it's not a good practice, but this is only for demonstration purpose. Actually, you have one concept that's called the data sets here, where you have some sort of publish and subscribe method. Okay, so if the new currency appears in the source database, we can send some event and trigger some DAG to load that currency inside the target database. Okay, it's much better concept to be used than this sensor here. Okay. And the last example here is this load currency rate. Let's see this example. So here I'm demonstrating the usage of the parameters and the usage of the variable. So here, when you specify a configuration of a DAG, you are specifying parameters that should be used. And I have one parameter that's called currencies. Parameters, concrete values for the parameters are USD and Euro. And the type, this is a validation schema for our parameters. It says it can be null and it should be an array, okay? A list of the currencies for which currency rate should be loaded. So now we want to load currency rate for some currencies, okay? Default value is this one. And inside our DAG, there is only one task that's called load currency rates. Here, we can read this parameter currencies, and if we didn't specify any currency, then we will load all currency that we have inside the database. If we specified some currencies, then we will extract only currency rate for those currencies from the source database. And at the end, we will load these currency rates inside target database. And here are also some messages. Sorry. Here is not load. Here is also extraction from the target database. We want to read if we already have this information inside the fact table. And if we don't have any records, then we should perform the initial load, but we are checking the dimension table. So after we check that, we can load our data inside the fact table. What is important? Here I specified the chunk size, in how large, how these chunks should be large when you executing these SQL commands, when you want to execute these inserts from the pandas data frame. And this is the way to read the variable that we specify at the beginning of this, at the running time of these examples. Okay, so after I execute this example, let's see if it will be success. Yeah, it's success. Let's see here the fact currency rate. So as you can see, we only loaded data for the two currencies, Euro and USD. Okay, and as you can see, there are only two values for the foreign key currency ID. 36 is Euro, that is located inside our dimension table. Okay, let's get back to the fact table. When we take a look at the value of 100, it's US dollar as a currency, and that is pretty much everything from my side about these examples that I prepared. So the purpose of these examples is only to discuss about some Apache Airflow code, concepts, role, and other possibilities. Okay, you have multiple references here, and that's it. Thank you very much for your attention. So I'm leaving now time for the questions. Okay.
All right, thank you, Miroslav. That was very interesting. Thank you, everyone, for attending the tutorial, being with us today. We're going to stick around for a minute or two to see if there are any questions. And tomorrow, we get ready to the continuation of our long, fruitful journey at Metropole Palace Hotel in Belgrade, and we'll see you tomorrow at 8:30. If there's anything that interests you, feel free to pop the questions in the chat, and yeah, Miroslav will try to answer it. If not, see you all tomorrow.
Yeah. Thank you very much, Tamara. I have one question already in the chat, in Q&A, actually. So thank you for the talk. Just one question from my side. How do we avoid using Airflow's memory for running ETL tasks which work with large data? Yeah, that's a good question. So how do we avoid this? So one thing is to have workers workers on different machines. The other thing is to use tools like Apache Spark or Hive or anything else that has its own executors, and then we will just connect from the Apache Airflow to that tool, to Apache Spark or anything else with SSH or even with Apache provider, and we will just specify what should be executed, from which source to load data, and which program or application to run to transform the data, and where to store that data. So we will just orchestrate this process. We don't want to load any data inside of the Airflow. So that's the one way to do this. Okay.
Žarko, does that answer your question? Were there any more? We are eager to hear them.
Yeah.
Yeah, Žarko is content with your response. Thank you.
Okay. Also, just one thing that I didn't mention here. Maybe you will have some issues with modifying these examples because after you run Airflow container, it will lock these files. It will change the ownership of these files from the users that are inside this container. So I will just demonstrate here. So when I enter this Airflow directory, here we can see that owner of the logs, owner of the DAGs is my user, but maybe you will see here 5,000 or root or something like that. How do you fix this? With the command change ownership recursively of to this user and to this group to this directory. And after you execute this, you will be able to edit this file if you are using the Linux machine. Okay, I will just send this message inside the chat.
Anyone who is interested, make sure to copy this. Okay, I guess that is it. So thank you again for the wonderful talk. And everyone else, see you tomorrow at Metropole. Goodbye.
Okay, thank you very much. Thank you all for being here. See you.